Tomorrow's quiz is going to cover a number of topics. I'm going to write down those topics real quick. Let's just basically talk about them. Section 1 talked about magnitude. It talked about direction.
Is this kind of going to be like the quiz we took the other day?
Take the quiz we took the other day and add on the stuff we did yesterday. That's it. Okay? So a lot of you, with a little bit of extra parts, so maybe you've gotten 3/4 of the quiz. I'm going to give you the majority of the period. Shh. I'm also going to have little personal conferences with you tomorrow about recommendations. So that's what we're going to do tomorrow. But the quiz I'm giving you most of the period to work on it. Okay? I don't know how much it's going to take. I'm giving you the whole period. I believe there's about 10 problems to go if you add up the pieces on it. So it's a full-length quiz. I should expect majority of people to take most of the period, maybe not all. If you have time afterwards, I will talk to you. If not, I'll talk to you next week. It's fine. Let's go back and talk about this. What's the formula for magnitude? Good. X squared plus y squared. What's the formula for direction? Tan inverse of y over x. What are some other things we talked about in section 1? Okay, good. Unit vectors. If I had a vector, let's say vector 1, 2. I want to make this a unit vector. So we want to turn it into a unit vector. And Dalton, what'd you say? I divide by the magnitude. So let's go ahead and find its magnitude. That's going to be 1 squared plus 2 squared. That's going to be equal to the square root of 5. So the unit vector becomes this. Good. 1 over the square root of 5, comma, 2 over the square root of 5. No big deal. Okay? Good. Another part we talked about was, section 1. Finding a vector from 2 points. This is kind of real elementary. What do we do to find a vector from points? Terminal minus initial. Okay?
I feel like that's the hardest part.
Yeah, I know, right? You got that down. There's one other formula we talked about. It was what? Finding the angle between two vectors. Okay? That's cosine theta equals u dot v. Actually, that was probably from section 2. So u dot v over magnitude of u times the magnitude of v.
Yeah.
Okay. So what else in section 2 did we look at? Shh. Quit talking while I am. Dot product. So we had u dot v was equal to what? u1 times v1 plus u2 times v2. Okay, so u1 times v1 plus u2 times v2 gives me the dot. What does the dot product tell me? Shh, I need you to listen. Quit talking. What does the dot product tell me, Allison? What does the dot product tell me? If it equals 0, that means that they are perpendicular in nature. Okay? It means that they're orthogonal. Good. Some other things we talked about. Good, work. So what's work? Cosine of theta, magnitude of the force, the direction, so PQ, magnitude of that vector. That was for horizontal.
Wait, what is the PQ?
How far you traveled. how far you drug the object, or how far you're pulling it.
Will it tell me in the problem?
It might tell you it goes from this point to this point. You just need to find out how far that is, distance formula.
Wait, what's
I have a
the
question.
formula?
Or the magnitude of a vector, if they told you the
What's the
vector.
difference in the magnitude of F and the magnitude of
Okay, so F is the force.
That's
When I
just
tell
not
you
given?
that this is, you had to use 13 pounds of pressure to make this part
So
move.
that's just given.
That's given to you. Generally, that's going to be given to you in that way. I could tell you he traveled from P to Q. P could be 1, 2, and Q could be 5, 6. And you might have to find the distance between. So all you do is find the vector, subtract terminal minus initial, and use the magnitude formula.
Will you ask us to find the force?
No. Oh, for work problems, the only thing you need to know is, in fact, tomorrow that's not even on the quiz. Okay, work's not on the quiz. Work will be on the test. There is a word problem. We'll get to that in a minute. But
Wait, I have a question. What's PQ again?
the distance,
This
how far you drug the object. Okay? Because if I'm more likely to press the home button down here than if I am up top. It's right side up here.
Why does it matter?
I'll leave my programming. You won't see any difference, but I won't be able to write on it. Okay. The last thing we talked about, and we're going to kind of start working on things, is we talked about yesterday as polar coordinates. Shh. Now, listen carefully. Shh. Listen. Polar coordinates, I'm going to ask you to do a number of things. I'm not going to do some of the harder stuff. We'll save that for the test. Okay? But polar coordinates, we talked about converting to polar form. What's x equal to?
R cosine theta.
What's y equal to?
R sine theta.
Good. What is r? But what is it?
X squared plus
X squared plus y squared.
What's theta?
Tan inverse y over x.
Y over x. So, funny enough, these formulas that we have are no different than what we've been working with in the previous sections. So there's no new formulas to memorize. You will need to know these tomorrow. Now we did talk about a few other things in terms of polar coordinates. We talked about, effectively, I need to convert from polar form to rectangular form in terms of points and equations. We talked about using the multiple representations of a coordinate, which we're going to talk about today. And we're going to look at the beginning. We're going to go back to the beginning and talk about equations. So let's do that real quick. Here we go. I want you to practice this because this is going to be the part that you're going to probably need the most work on. This and maybe that if you haven't gotten the multiple representations down. We're going to spend a good bit of time on that. All right, let's do this one right now. Number one, yesterday, I did this a problem like this real similar in class. Okay? Listen. I'm going to work these out for you, and I want you to pay attention. If you had r equals negative 2 cosecant theta, and the instructions say convert this into rectangular form, effectively what that means is I need to get rid of r and theta and replace them with x's and y's. Okay? We know that because we have our formulas. X equals r cosine theta, y equals r sine theta. So if I could get r sine theta or r cosine theta, I can switch those out with x's and y's. And that's kind of what we're going to look at here. We're going to divide this by cosecant of theta on both sides. What does that do? That's really r sine theta equals negative 2.
Y equals.
Bingo. So that's just easy, straightforward. Y equals negative 2. What you're looking at right there, that if I were to label this would be the easy version of these calculations.
How do you do the x? Is it the same thing?
Remember yesterday we did it and I told you it was secant theta?
Yeah.
And you just divided by secant and you got cosine. You get that? You do not have to have x and y. You just can't have r and theta. As long as you get rid of those two things, whatever's left is the answer. And so that is all we have. That's our answer here.
Wait, how do you find the x for that
And
problem?
there's no x.
There is no x?
No x. That equation, if you were to graph it, would be a horizontal line.
Okay.
So there's no x at all. Some equations will have x's and y's, like the next one we're going to do. Some equations will not. Now, this next one, pay attention closely. This one's more difficult. I'm going to ask you to remember how to do something you may not remember how to do. Here's some notes to take down. When you have a problem like this, 2r, or number 2, equals r equals 4 cosine theta. I would love it if I had r cosine theta, but I don't. Okay? If I had r or r squared, I could. What would r squared be in terms of my x's and y's? It's x squared plus y squared, because r equals the square root of all that. So if I square both sides, I get r squared. So that's easy. So what we're going to do, your choice in the problem like this would be either to square both sides or to multiply by r on both sides. I want to get r squared. That's the goal. But my choice here, if I square the cosine and I get a cosine squared theta, then I'm in a lot more complicated situation. So I do not want to square. So we're going to multiply by r on both sides. Right? And so that's going to leave you with r squared equals 4r cosine theta. That's the best of both worlds. On one side I get r cosine theta. On the other side I got r squared. So I can just immediately go in and switch those out. So that's going to end up being, this will be x squared plus y squared equals 4x. Now I'm not done, unfortunately. If I were done, that would be just as easy as the previous one. I'm going to ask you to remember how to complete the square. Okay, so this becomes, I'm going to simplify that expression just a little bit. That's going to become x squared minus 4x. I'm going to leave a little space. That's plus y squared, and that's going to be equal to 0. So, remember what the key to completing the square is. It's b over 2 squared. That's the object that I need to remember in order to complete this problem. So what we're going to do, let's look at this. Which letter, which variable am I going to have to complete the square for? X or y? Just for x. If you just have a y squared by itself, leave it. It's good to go. If you just had an x squared by, leave it. Whatever you have the single x with, or the single y, that's what I would have to complete the square with. And I could have to do it for both, but this time I don't. So we're going to go back over here. What am I going to type in, or write in, what is b squared over 2? Well, b is going to be negative 4, right? So it's going to be negative 4 over 2 squared. So that's really negative 2 squared, which is just 4. So what we're going to do is we're going to add 4 plus 4 here and plus 4 here. See that part? That's a perfect square polynomial. I know exactly what's going to happen to that because I made it intentionally. Without even thinking about factoring, I know the negative 2 goes in right there. How do we know that this is negative 2? Because that is what it was right before I squared it. Okay? I have to remember what it is. I just take basically I can just divide b by 2. So it's going to be plus y squared equals 4. And this is my answer. I'm about to explain. Why would this be the answer? Because, do you remember this? You should. What is that form of?
It's a circle.
You did. It's a circle. So what we have here is we now have a circle at center 2, 0 and a radius of 2. This is why we leave it like this, because this is the standard form of a circle.
So if you were to keep going, you get it wrong?
No, but you've already keep going and solve. You solve for y.
Well, like, can't you take the square root of both sides?
No.
Can't.
No. What I could do is I could subtract 4, or I could subtract the x squared minus 2, x minus 2 squared on both sides of my equation, and then take the square root and add plus or minus, and that would still be okay, but that's more than you need to do. Okay? So this embodies the more difficult type of equation that comes out of this section.
And you said that's not gonna be on the quiz tomorrow.
I didn't say that.
You said the more difficult wouldn't be on the quiz tomorrow.
It's not, but I didn't. Did I say that?
Yeah.
Okay. No, the difficult part is not. But it will be on the test. What I just got through talking about, no. Well, solving equations is, yes.
But that's.
But this harder version is
Number
not.
1 is on the
Oh,
quiz. Will planes or boxes on a ramp be on the quiz?
Yes.
Both of them?
No. Just the ramp. The plane will be on the tests. Okay? Now, let's go on and finish some of these out. I want to look at some of your homework. Okay. Get some paper out and work these out. Now, here's the important. Let me go back over it real quick. If I give you a radian angle measure, you don't have to do any conversion. You just make sure that your calculator is in radians. You type it in just like it looks, and it works. For 15, I need to be in radians. I type it in, I use my formulas, and I'm getting 0.75 for x and 1.3 for y. That's my coordinate. Number 21 is even easier. 21 is directly south. It's directly down from the origin, right? So x is going to be, and how far down did we go, and y? -2. I wouldn't expect anybody to do work on that one. If it's straight down 2, where would I be on the xy coordinate plane? 1, 2, 0, comma, -2. I can still use sine and cosine. R times sine, R times cosine. They still work out great. Shh. Questions? Okay. Yes, ma'am.
Is this written down right?
Shh. Listen up. Let's do another one. Let's do 24 real quick, because I want to spend a little bit of time on this one. Shh. Okay. Quiet. Put your cell phones up, or in fact, just hand it to me. Thanks. Pay attention.
So that's really,
If I just plot this, you're going to get this particular place. Okay? I'm negative pi over 4 degrees, or like we said earlier, could be 7 pi over 4. I'm just in the 4th quadrant. I'm 45 degrees down from the 4th quadrant, or from the x-axis. And so now you have an angle. My question is, how can I get to that particular angle measurement? So here we go. Watch.
is that just a plot?
The way that I want you to interpret this is you're giving me directions. It's like a treasure map. I have X marks the spot. There are 4 ways to get to the same spot. Here are your rules. You're allowed to turn in circles, and you're allowed to either walk forwards or you're allowed to walk backwards. That's the only directions that you can go. So the first one says, okay, so if I'm pointing towards the horizontal axis, the positive x-axis, if I turn negative pi over 4 degrees, and I take 1 step forward, then I'm at my point. Okay? So here's the first thing. So we have that point, that's easy. That's the point they give me. The second point that you want to find is going to be 1, comma, and to go from here to here, the only thing you have to do is add 360. Okay? So let's do this. Let's convert to degrees. So you have 1, 45, or negative 45. Just to make this a little bit easier, we're going to go ahead and set this up. -1, -1. I know that my angles, I'm going to have two positive angles and two negative angles. Your restrictions on angles, they can be as small as negative 360 and as large as positive 360. If you get a number that's outside that range, it means that you should have added when you subtracted, or you subtracted when you should have added, whichever way. Okay, go backwards. So to go to the second one, we're going to add 360. What's negative 45 plus 360? It's 315 degrees. So if we look at our diagram, if I turn, remember we start facing this direction. So if I turn the other way and I go 315 degrees, so if I turn all the way around, 315 degrees, and I take one step forward, I'm at that location again. So that would be 315. To go from here to here, it was plus 360. When would I subtract 360 here? If I had a positive angle to start with, I'm going to subtract 360. Because if I had a positive and I add 360, I'm going to get a number bigger than 360. I would know that was wrong immediately. And I would go backwards the other way. Okay? So now we have an issue, because now what we have is we have to go to the other side. So now I need to go all the way here. What angle would that be? If I'm started at the x-axis and I turn this direction, so I'm going to go back to my original angle, and to get down here, I'm going to add 180. So that would be 135. Now, if you think about it, I turn to 135 degrees and I take a step backwards because my radius is negative 1. Negative would mean you would back up to get to the spot. What's the other way I can get to the spot? Exactly. I can say, okay, well, I need to go backwards this direction to get here. So how would I get to that spot?
Subtract 180.
So if I go from here to here, I'm just going to subtract 360. Didn't I just want to turn around a complete circle in the other direction? So I'm still pointing the same way. I just want to go the other way to get there. So that'd give me negative 225. And there are my results. Now let's go ahead and rewrite this in terms of radian measures, just for practice. So we obviously know that it's 1 comma negative pi over 4. Positive 7 pi over 4.
3 pi over 4.
Okay, and then we have negative 1, 3 pi over 4. We have negative 1, negative 5 pi over 4.
Are we allowed to do it in degrees or?
I don't really care. Okay? At this part, it's just getting those coordinates down. Questions? Let me back up a minute. Let me recap this. First thing we started with was a coordinate. I wanted to convert this into all of its forms. There's 3 forms that I'm interested in. Those are the other versions between negative 360 to positive 360. The first step, I take my angle that they give me. If it's negative, I'm going to add 360. If it's positive, I subtract 360. Got my second point. That's all you have to do. Okay? The third point, I go back to my original one. I'm going to add 180 to it. And I change the sign at this point. Now I have negative radii. I just add 180 to my original one, and I change the sign of the radius. The fourth point, I take the negative radius and the angle that's with it, and I'm going to either add or subtract 360 again, and I have my fourth one. You need to practice this to become familiar with it. Okay? It's a little too many steps back and forth and around the corner to get just directly to the answer.
This won't be on the quiz, right?
Yes, this will be on the quiz. That's why I'm making a big deal of it right now. Okay? You can watch this video. Okay? The video from yesterday and today has an example. I mean, they're both exactly the same. Okay? So watch those and make sure you know how to do this. Okay? Your homework. The homework that I'm assigning in terms of the problems are just the practice problems that we did at the beginning of class. 35 we did in class on the board. Okay? The rest of them are the ones where you have to convert and using the, you convert from polar to rectangular equations. I need you to review 6.1, 6.2, and 6.4. I pretty much gave you everything that's going to be on the top in terms of topics that's going to be on that. The one thing that we didn't talk about, look on the screen. You have the ramp question. Let's say it's got 1,000 pounds. Let's say this is 20 degrees. Be able to set this little triangle up, right? And so you've got your right triangle. It's 1,000 pounds. You know that this is 20 degrees, and if I wanted the force holding it up, I'd find that one. That would be 1,000 times the sine of 20 would be x.
But no plane question.
No plane. We'll save the plane for the test. But make sure that you check out these. Remember, the videos are online from most of our classes during this time, as well as actual tutorial videos on the separate lessons by themselves. There is a video just on doing a problem with the ramp question. Okay? It's about 5 or 6 minutes long. It's really more about how to set that triangle up and what the forces are. I am making too many videos, but use them or not.